Okay, so for this section of differentiation, we're dealing with the how do we differentiate triple. So there are three basic functions of triple: sine, cosine, tangent. So the formulas are here. Okay, I need to do a basic explanation first. Okay, this formula will not be provided during exam. So you kind of need to memorize the formula, but not to worry about that. Gradually you will remember it. Okay, so the main formula will be something like the blue box. The blue box is for the trigo where the angle is x. So when the angle is x, right, you just take note that differentiate sine give you a cosine. So differentiate a cosine gave you a minus sine. Differentiate a tangent give you a secant square. So that's all you need to know if the angle is x. So in my head, right, to me, it's always like that. Sine become cosine because it's a differentiation formula. Cosine becomes minus sine because that's also a differentiation formula. And then tangent will become a secant square. So in my head, that's how the formula works. So the only difference is whether the angle is x or whether the angle is not x. Okay, so the second box, this red color one is not very useful. Okay, so I will say that it's not very useful because, right, I can just rely on this one, this box. So this box is for when the angle is not x. So the angle is not x. That means the angle can be any function of x. So if you look, the angle is a fx. So this is also like a fx. It's a linear function. So this is also like a fx. So the red color box is for fx being a linear angle. Okay, so I will explain the blue box first. The blue box are the essential one. So when the angle is not x, in this case, angle is not x. Angle is fx. So what do? You think of it as layer. You differentiate the sine first into a cosine fx. Sine fx becomes a cosine fx. Then you separately differentiate the angle. Then cosine fx, when you differentiate, it becomes a minus sine fx. So you just copy and paste. Okay. But then, right, you separately differentiate the angle. So you must differentiate the angle separately. Then if it's a tangent, you differentiate tangent, it becomes a secant square. But then you also must differentiate the angle at the back. So basically, you think of it as two layers. You differentiate the triple function and you differentiate the angle. Okay, so of course, when the angle is fx, it is ax plus b. Differentiating it is very easy. If you differentiate ax plus b, you will just get a a. Okay, of course, the function has already been differentiated. So sine has been differentiated to cosine. Cosine has been differentiated to minus sine. Tangent has been differentiated to secant square. So you see it as two layers. One layer is the function, another layer is the angle. Okay, so it maybe if it looks complex here, okay, I'm going to show you through some numerical example. So I'm going to show you the basic one first. A and B will deal with when the angle is x. So if you look at 1a, the angle is x. So differentiate sine, become a cosine x. Differentiate cos, becomes a minus sine x. That's just according to the formula. Part B, when you got a 4x squared, you apply your usual bring down power minus power. So you got 8x. Okay, tangent, differentiate tangent, that's just a secant square. And that's it. That's the answer. Okay, part C, our angle starts not to be x already. So our angle starts not to be x. So you differentiate sine first. Differentiate the function first. When I differentiate sine 3x, I get a cosine 3x. Then you differentiate the angle on its own. Differentiate 3x is a 3. Okay, cosine 4x. So when you differentiate cosine, you will get a minus sine 4x. Okay, the angle doesn't change. Then after that, I additionally differentiate the angle. Okay, so be careful of where the number goes to. This 3 goes to the function. It doesn't go to the angle. Please don't go and do it as a cosine 9x. Okay, it doesn't go to the angle. It goes to the function. The 4 will go to the function as well. So it doesn't go to the angle. So be careful of that. Some students, they might make this kind of mistake without knowing it. Okay, so this is like 2-layer. So the next one is the same thing. Okay, the next one looks a little bit complex, but it's actually just a linear function for the angle. So you differentiate the function first. When I differentiate the function, differentiate cosine gives me a minus sign. Then additionally, you differentiate 2x plus pi over 3. Pi over 3 is a constant. So if there is a constant, then that's a 0. So the 2 is multiplied to the function, not to the angle. The angle stays as 2x plus pi over 3. Okay, so the next one, if there is a coefficient here, like a 3, ignore the 3. Just let it be there. Okay, differentiate tangent, become a secant square 2x. Tangent 2x becomes secant square 2x. Then differentiate the angle on its own. So when you differentiate the angle on its own, it is multiplied to the 3 in front. It doesn't get multiplied to the angle. So same thing here. If there is a 6, leave it alone. So this is tangent 1/3 x. That will give you secant square 1/3 x. Then you differentiate the angle. So the 1/3 goes to the 6. It doesn't go to the angle. So 1/3 times 6, that will be a 2. So review this example. This example is a case where if your angle is x, you just need to differentiate the function. If the angle is not x, then the angle become an additional layer of differentiation.